You got it?
I got
Should
it.
be
Thank you.
awesome. Yes.
All right,
All
well,
right, thank you
take it
so
away.
much.
I was just gonna say, take it away. Well,
So yeah, today I'm going to be giving you an overview of what the school project is and kind of what our goals are with this project. What school means is the Science Core Heuristics for Open Science Outcome in Learning project. And this is part of the Open Science Training Initiative that is part of the NASA Transform to Open Science Initiative. If any of you haven't heard that, there's an initial project that NASA has already kind of rolled out in terms of the beta version called Open Science 101, and I can send out the link in the chat where there are modules that teach people about what open science is, and maybe I have some slides on that. So I'll just get started here. This is the Open Science Code of Conduct. I always like to start with this because it kind of encompasses what the entire goal of it is. Um, Practicing empathy, humility, including more communities to be kind of become part of a broader community and be able to be active and contribute to science and research. So this is kind of code of conduct that was developed by the TOPS team, in which we always like to show it. So, what is the Transform to Open Science mission? It's a mission by NASA, as I mentioned, where they want to have new discoveries and solutions through inclusive and open science collaborations. So the goal is, or the vision is that collaboration will be the starting point where these great scientific discoveries will happen. Um, the mission as well for this project is to empower scientists, researchers, students like ourselves to embrace open science and to learn what that is and how to properly practice open science. And so through this mission, the objectives that were developed were these three at the bottom that you can see where is to accelerate scientific discoveries, um, broaden the participation, especially by underserved or excluded communities, and increase the understanding of open science principles. And down here, I can share these slides with you as well as their GitHub pages. This is kind of a concept of open science. Open science is meant to be accessible, reproducible, and inclusive. And then within these three inner bubbles, you have more subcategories. So open science is almost like an ecosystem. And there's a lot of different fields and areas to not only to work and develop and focus on, but that they kind of also have to work together. So one way to visualize this when we're talking about research is that the value added is that researchers would be cited more, it would have a bigger impact, it increases transparency and inclusivity, um, and it also allows us to create these new collaborative projects in which we're all a part of, and to access some hidden knowledge that perhaps we can share with you, and then vice versa, and then we can then share with the greater community. Um, so yeah, the goal or the kind of big picture is that NASA is asking for more people, more hands, brains with diverse experiences so that we ask better questions and find the best solutions for these global issues. So I mentioned the Open Science Open Core 101. These are 5 modules that you can take online. Each module, you kind of get this certification. on open science. And then if you complete all five, you get a open science badge. I think they mail it to you. Um, so all of these are kind of the five themes of open science. And we hope that with your help, we can also introduce these five themes into the curriculum that you've already started to read. The first one, of course, is ethos of open science. That one just kind of talks about the what is open science and what's the point, and kind of these kind of ideas. Once you understand those base level ideas, then it gets more into what are the open science tools like GitHub, and I'll show you a few tools. What does open data mean? So that includes, giving credit, receiving credit, and citing things properly, uh, things like that. Open software, using languages like R or Python, free software like RStudio or Visual Studio Code. Now we're using GitHub for this project and using the pages, as well as we're using Shiny Apps websites and some other ones. And then of course, open results. How do you share your results so that people can replicate them? For us, we're representing this through these recordings and publishing them on Zenodo, and sometimes making YouTube videos and publishing those YouTube videos. And that's just one way to do it. There's many ways to do it, and there's many ways that we haven't thought of or NASA hasn't thought of. So this is kind of meant to be a community effort in many ways. So now focusing into the project that we were talking about is part of the science core, which is the continuation of the Open Science 101. The science core is a way for NASA to start engaging with researchers and to kind of demonstrate and researchers and students how NASA or how open science can manifest. And so in this science core, Professor Tovar is part of it, as well as Robin, in terms of, there's different projects that are going on within this science core bubble that aims to show and showcase what open science is. So in our for the school project that we developed, we were doing 2.5-hour modules that focus on data science skills. So we try to give some sort of narrative as well as coding that comes along with it. And this is some of the partners that we're working on. We work with some local universities, Baruch College, some of the CUNY, these are state universities and city universities, as well as iSciences, which is also a private partner. CDAC is what Kit was mentioning. That is the NASA side of the socioeconomic data. So from them, we're kind of taking a lot of the data sets that we're using to as kind of dimensions of humans, and so the idea is that with these kind of human data sets, how can we combine them with NASA satellite data, or how can we create these projects that help people become more sustainable and more inclusive? So as I mentioned, the project it aims to develop a curriculum which incorporates earth science applications and uses data into the data science lifecycle. They are designed as learning modules for both online, and now we're starting to kind of try them out with the 2I2C environment, which we'll talk about in a little bit. To see how this can also be used as in-person instructions. within these modules, or each module will focus on a different theme, which you see here at the bottom. So the ones that you've been reading so far are on water, but we hope to include health and air quality, environmental justice, disasters, wildfires, agriculture, and climate. And then, within the modules, some of these themes will overlap in anyway. So on top of these themes, as I mentioned, we want to add another dimension of population and infrastructure to see how these agricultural measures or health and air quality, how do these get impacted, or how do these things interact with population and infrastructure, and how does population and infrastructure in turn interact with the themes. Each module is structured in a way to go over the data science lifecycle. So some of the modules are designed to teach the learner how to generate and collect data, and then as you go down the module, how to process it, store it, how to manage and analyze the data that you downloaded, how to visualize it, interpret it, and then the last part is how to engage or how to share your data with the community so that other people can either reuse it or can share it with other peers. So our goal is also to have each module be in two languages. Right now, the first one, we're still working on the English one. Once that's kind of a little bit more complete, we'll translate it into Spanish. Although we have had some, setbacks with translate into Spanish, particularly because the research that we're citing is in English, and there's not necessarily Spanish translation for those citations. So that's a challenge that we're facing. So we hope that maybe in the future, one of these modules will be developed in Spanish first, and then translated into English. In the spirit of open science, we're trying to develop the project as kind of as an agile project management framework. So it's a little bit looser. I don't know if maybe Kate can jump in here and add some more information.
Yeah. So, you guys are computer science majors, so I think it's likely you've heard of Agile before, but just in case you haven't, traditional software and data development procedures followed an approach that has been called a waterfall approach. And basically, it was the idea that you complete the project and then you release it to beta and to production, and not until it's finished. Whereas in an agile process, there's this idea of continuous integration where you're releasing software or data, or in our case, curriculum, as it's being developed. And, the thought is that through doing so, you'll be able to identify issues earlier on in the process. It really is in line with some of these open science goals of including more people in the development process itself. So within our project, we're doing our best to adhere to these agile frameworks, but as Juan mentioned, it's a challenge. One challenge that we're facing is that our team we're geographically distributed and we're working all on different schedules. So in a traditional agile project, you would do things like a sprint, which if you've coded before, you've probably maybe even participated in hackfests and sprints. It's been a challenge for our team because our schedules are very divergent. So I think in practice, what we're doing is a modified agile process, but still we're seeing the benefits of that in that, you guys in particular, you're reviewing something that we don't think is a final product yet. And the advantage there is that you're able to influence how the final project will end up. And so, we're appreciative of that. So we're agile in our aims. In practice so far, we've been maybe 80% agile because of some of the practical ramifications. I just hand it back over to Juan.
Thanks. So these are some of the folks that have been so far helping out. This is what we call our development team. These are, as I mentioned, the institutes that were part of the proposal. So these are kind of our core team that reviews the information and all the feedback that we're receiving from more exterior partners or more exterior cohorts. And then this was our primary objective for the water module, which you've been reading, is to, well, for every module is to identify data sets that we can use and showcase. So these are the three that you'll be reading about. The first one has the two first case studies in the module, and then these two are separate modules, separate case studies in the same module. The water resources data set, it talks about return periods, water return periods or deficits. And we use it to show how to download data, but also to plot data and to just visualize it initially and to subset data. The water one, the near real time, is focused more on how to accessing data that is current, whereas this water resources one on top here, WSIM, is historical. It comes from 1948 to 1914. This data set, the second one, the near real time, is a rolling data set, meaning that they only have available maybe a week before, and then every day it gets updated. And then we have a more localized or hyperlocal data set that we're also looking at, which is a data set that is New York State lead in schools. And this one, has several characteristics on school water data. So in order to present this project, we had to use several technologies. We are basing the module on these languages, Quarto, R, and Python. The first one we did, the first module on water, we started in R. I think it was because, someone working in that space mentioned that, R is the primary language that they use for these kinds of data sets. So we started with R, but the next iteration will probably be in Python. And hopefully maybe down the line, we'll have a version for both languages. We're using RStudio and Visual Studio Code to manage all of the files and managing the GitHub repo. RStudio, we're using it because it uses R, but VS Code is also a good IDE. It's an integrated development environment where you can read both R, Python, and also Quarto. So we're using these two environments to code everything. Once we code everything with these two, we're using several online open repositories to share information and share the work. Primarily, we're using GitHub, where we're storing each module as a repo. And then we're also using GitHub pages to provide general data about the project and provide updates. Zenodo is an environment that you can post a lot of research papers or updates or presentations, and it uses the OrcID system. So it's a very efficient and easy way to give people credit for their time and their work. So if we post this video on Zenodo, we hope that we can give you all some credit, and that will be then linked to your org ID. And then, of course, I already mentioned CDAC or the NASA DACs. These are distributed around the country. These are data centers that have different types of data sets. One of them being CDAC, but we hope to use data from different data centers as well. And then we're starting to get into the online interactive code, which is, for now, we're using 2I2C. So hopefully by next week, I will have to ask you all to send your GitHub ID. If you don't have one, you can create one. It's free. With that ID, we can provide you access to the 2I2C environment that has the water module with the data installed. So this is one way to kind of make this entire framework interactive. There are other frameworks that are out there, like Jupyter Hub and Binder, and each of these, has their limitations in terms of computing power or accessibility. So they all have pros and cons. What's great about 2I2C is that it has a lot of great computing power, and they're also a partner with the TOPS Science Core initiative. So it was just a great opportunity for us to work with them as well. And so the idea is that putting all these things together, we build something that's, very beautiful, that's appealing to people, that people want to use, because very often in science and in research publications, and this is something I complain about a lot, is, they're very, text on a paper and not very accessible to new learners. So one way to make it accessible is to, enhance the user experience. But that it still maintains that, peer-reviewed publication quality information.
Can I interject for a minute there, Juan? You're okay with that?
Yeah, please.
I wanna sort of I put the org ID. I know you talked about that. When you take the NASA TOPS summer school that NLU is involved in, we require you to create an org ID. And org ID, that stands for Open Researcher and Contributor ID, right? So it's free to get. You just go to the site orgid.org. You get it, and you get an ID for that, right? That's what Juan was referring to in terms of, hey, we can, once we publish stuff, we can kind of refer to that org ID and all that stuff. And it's sort of an identifier that follows you through your research process, right? And you can tie in efforts to that. In terms of coding languages, I know the content is R, and I know most of you, if not all of you, don't know R, but you know Python. And I know R, so Python is very similar to R. And so we're gonna come back later, right? We're gonna come back later because right now what the cohort is doing is just reviewing the content, understanding the content, and everything. Once we get 2IC2 resources, then we can start working on the code part of it. I tried to run one of the files. It was huge. I have a 32 gig machine here. I couldn't run it. It's just too big, right? When I was trying to run the R code. So that's why we're waiting for that. In case, the students here are sitting there thinking, okay, how are we gonna run this R code, right? So don't worry about it. I'm gonna walk you through the whole process, right? I ran most of it, by the way. I'm just gonna run the bigger file processing files over there. So this wanted to gonna jump in and kind of give you, put you at ease from that perspective. I am hoping that you guys eventually, the Columbia team, can come back and say, hey, we're gonna be developing this in Python, because a lot of the projects that this group has worked on, when they took CSS 300, that's where we actually teach him data science and statistical work with data and everything is done in Python, right? So they are very versed in Python, and they can visualize that in Python in many different ways, right? And we can definitely help with that in the future. You guys say, hey, we're looking for Python resources. Hopefully we'll still be here. And you guys can reach back and say, hey, Antonio, you mentioned this, we're gonna take you on that, right? And we can kind of organize some of that work for you guys. Okay, Juan, thank you for allowing me that little space there.
Yeah, that's great. Yeah, that's another great avenue that we can continue to work. As I mentioned, our right now we have the lesson in R, but if the lesson could be in both languages, it would, it would have even greater value. I do agree with Professor Tovar that R, if you know Python, R is pretty similar to Python, so you shouldn't have any trouble picking it up pretty easily. And of course, there's Stack Overflow that has everything there. So yeah, but these are the frameworks that we're hoping to use, and of course, making them better and more accessible is the goal.
Yeah, Juan, I could give a sneak preview here of the 2I2C instance.
Oh, that'd be great.
Sure, yeah. If you want to start setting that up, I'll finish this, and then we can
sounds good. Sounds good.
As I mentioned, we're using GitHub to store all the files. GitHub has the advantage that, many advantages that kind of speak to the open science principles. You can get requests, you can message the creators and tell them, hey, there's an issue. You can apply updates or suggestions. And what's great about it is that it reads Quarto markdown documents, which then render you a very nice HTML page. I don't know if the professor was able to send out the links, but those pages were rendered out of this GitHub environment using Quarto. And Quarto is just essentially like a new extension, but I think it's pretty much like R or similar to Jupyter notebooks. So some of the milestones that we had, we went to the NSF iGuide in the fall. Was it in fall or maybe last spring, where we kind of first started introducing the first module. As I mentioned, we started several online communities in Zenodo, in YouTube, and we've also started to share, the links with all of you, and gone to a few workshops to show these links. This is what the Quarto rendered HTML page looks like. And it's meant to be a little bit more welcoming for people. And we're already started working on the next module, kind of starting the development process and the planning process. And these are some of the variables or data that we're thinking of looking at. Although in our last workshop, some of our subject matter experts that are helping us inform this module mentioned that it's a much better approach to kind of start local analysis, and these variables here are very much global analysis. So we hope to use these two viewpoints, but certainly emphasizing the local perspective first. This is another module that we are working on, but in our most recent discussions, we hope to include environmental justice in all of our modules. So if you as you read the documents, if you see a part where you think, oh, this would be great to discuss some topic regarding environmental justice, it would be a great addition to the module. Again, these are some variables that we looked at. And then recently, I mentioned that we had this panel session at AAG. a few weeks ago. And the talk was on health and air quality, environmental justice. These are our subject matter experts, which gave a presentation, and based on their presentation and their slides, we then developed the module. So it's a very collaborative process where subject matter experts first and foremost, and kind of give us this guiding information, and then we work with research assistants or students such as yourselves to try to do a little bit more research and case study research to develop more of a narrative, and a narrative that is based out of the information received from these subject matter experts. And then once we have kind of this narrative overview, then we start including asking questions about what kind of data do we need, what do we want to display, and start tying in these more computer science components to the module. Some of the opportunities that we identified trying to practice open science and the agile style of project management is that we definitely saw that there's a very high interest in across many communities to learn more about open science and to be able to practice it correctly. As Kit mentioned, the agile project management style increases participation with a wider variety of stakeholders, and this participation starts much more early. We're using technologies such as GitHub and 2I2C to facilitate FAIR principles, and these are principles that come out of the Science Core 101, and it's a broader community as well. But essentially, we hope that data science becomes findable, accessible, interoperable, and reproducible. And finally, we're getting early feedback on the modules. I see a lot of you already making comments and adding new citations to the document. So this is just making this early feedback process is making the material more accessible and more robust. Some challenges that we're having with practicing open science is that the interpretation of open science varies widely. Some people think that open science means, that it's free. Some people, think, well, someone has to pay for this. Open science means sharing. Some other people think it's regarding, blockchain technology or preventing fraud, inclusivity. So there are all these kind of ideas about what open science means, and they're still not we're not still aligned yet on what this means. So that creates some challenges when you're trying to communicate with others about what you're trying to do. The agile project management to implement this style took a lot more time at the beginning to set up and to be able to kind of receive and process feedback. So it takes a lot of time and people, which requires salaries and computers and time. So, and it's my opinion that this is not cheap or free, but that it's meant to be inclusive. And it's my opinion that NASA, through these projects, is showing that it's willing to invest in open science. The development of the infrastructure, setting up the GitHub pages, getting all these documents ready, took a very long time, which then took away from focusing on the curriculum development. So that was kind of a high cost that we had at the beginning. But now that all that stuff is set up, the costs of that setup have gone down. And as I mentioned at the beginning, Spanish material is scarce to find. AI is helpful in kind of getting an initial, translation, but it still misses a lot of context that is necessary for, a lesson. So you still need someone to kind of go over it and review it. So we're looking at other avenues to, they have some other chatbots that are more advanced. Some of the NASA partners. So maybe we're looking to, partner with them to see how we can use their systems to either translate the data or to help with this area. And then we're also working with another partner from the Science Corps, which is called Metadocencia. They're an organization in Argentina, and they focus on Spanish curriculum development. So hopefully we'll get to work with them as well. Thank you very much.
Thanks, Juan. Just a couple more things I wanted to show you guys real quickly. Can you see my screen? Okay, so Juan
Yes.
mentioned that we, our website for this project is a GitHub IO page. So I'll throw this in the chat, but I just showing you guys what the page looked like. One thing we'd like to offer you to thank you for helping out with the review is the opportunity to be part of the open science team for the project. So there are several folks that have already participated as open science team members. And, we consider that you guys are already doing this work. So, sometime down the road here, if you're willing to share a headshot, we'll put it up on the website, and then another way for you to get credit for your contributions to the work. Then we also mentioned that we will have 2 I2C backed Jupyter Hub instance, hopefully within the next week. Part of it is available now, but we don't have it quite working how we want yet to roll it out to other users. But eventually, when you get access, when you log into the website, you'll see something like this, and there'll be an image that is for the school project. So if you select that image, the resource allocation also, I'm not sure that these numbers in the drop-down list are quite right, but what we found is that the lessons, they perform relatively well at 7.4 gigs, and even better at 14. 29 is probably more than we need. But if I select 7.4 gigs of RAM and 4 CPUs, I go ahead and click start. Now it'll take a minute to spawn up the virtual machine for me. That actually went a whole lot faster than I thought it would. So it must not be a lot of people hitting the system right now. But once you have access, what it loads up is an RStudio interface, which I'm also a Python programmer. So R isn't, it's not as natural to me as Python is, but I do think that the learning curve, as others have said, it's not too much. It's basically when you write in R, you write a Python sentence backwards, and then you've written some R. It seems like the syntax is opposite, but the functionality is on par. So what you'll see is an R interface like this that operates like a Quarto notebook. So you've been familiar with the text, but now we'll have these blocks of code that we can click on and run. I'd already run a bunch of this code before showing the demonstration, but you can see how it produces the different images. And it, allows you to make edits to the code to test out different things. So that's where we're headed. And optimistically, by next week, we'll be able to roll this out for users. It is something that you get access to through a GitHub account. So, we'll follow up with an email to ask you about your GitHub username, and also if you're interested in being on that school yearbook page to share with us a headshot for that. So I recognize that we're getting close to 5 o'clock. So I'll go ahead and stop the share right now and open the floor for questions to Juan or myself.
Let me provide some comments. Thank you, guys. I think it seems like we are making excellent progress, right? You guys are doing great. So I already have a couple of headshots from students. I was waiting for everybody to send it to me. So if you're interested, send me your headshot if you have one within the next week or so. I'll pass it along to Juan, and then Juan or Kit, they're going to put it on the website and so on and so forth to do that. NLU, so you guys know, I'm also talking to Laura Accion, Juan. Been talking to her a while.
Yeah, that's great.
About collaborating in, making those translations a little better from a technical perspective. I'm a very technical guy, so I sort of subscribe to the fact that we need to have, a clear code and understandable code and narrative, right? And I think that it's important that there's a technical guy behind it saying, okay, this makes sense, it doesn't make sense, right? And I think it shows on the module that you guys have. I know that when you guys get to the Spanish version of the modules, this cohort is not going to be here because they're graduating. Yeah, right. They're graduating this year. But we are a Hispanic, we are what we call an HSI institution, and also it's a Hispanic servant institution where the majority of our students are from are Spanish, right? And a lot of them speak English. I'm sorry, Spanish, right? So just keep that in the back of your head when you guys get to that point. Say, hey, we know a partner who's a student body knows this language, so we can maybe reach out to them and also have that content tested and make sure it makes sense. So there you are. Thank you guys so much for a lot of information. If you can send us that PowerPoint one, a lot of good stuff in there, very interesting. Does anybody have any questions, like Kit mentioned, from the team here, to either Juan or myself or Kit? We're here to help you guys. Any questions, thoughts, comments? I think it's very exciting that you guys are looking at the different, sort of areas, right, of climate and water and air quality and all that stuff, because that's an impact that everybody is going to get affected by, right? Everybody. So we need to know exactly what's out there. So I'm very excited that you guys are doing that. Now I'm gonna quiet down so that we can get some questions or comments from the group here.
Yeah. I just wanted to add that, I hope that all your documents and your comments can perhaps, at the end be somehow, as a collaborative project be put together. And then, in the spirit of open science, sharing that with us as well. So that's, just for your understanding, where does what you've been doing fit in is in that space that, we hope that your contributions will ultimately end up in the website and in the module. So yeah, but as I mentioned, it is a tedious process to put it all together. So any help with consolidating that feedback would help a lot.
We're gonna be talking about that towards because we have 10 weeks. Remember that, right? So this effort, everybody committed. Alina, Jorge, Iker, Nick, and Jonathan, is a commitment of 10 weeks, right? So 10 weeks at 10 hours a week is a lot of time, right? So I'm already planning in my head, hey, we're gonna be probably towards a week 4, 5. When I get to the code, hopefully the resources to run the code and to figure that stuff out will be there, and I can give the students here an overview of R for an explanation. Right? You don't really need to know R. The code should run. Right. Let's look at it from that perspective.
Yeah,
right?
one thing we need to know is that we don't anticipate that people coming into these modules are going to know either Python or R. So it's actually a good test for us to have someone come in who's not used R before and to say whether or not this makes sense.
Exactly. Exactly. I was thinking about that, kid. I'm like that, because not everybody, guys, you are computer science students, right? And remember the audience for this is everybody, right? So the goal of this research effort is to provide the tools and the knowledge and the content of these data sets, right? And how they contribute to knowledge and how they help us make decisions, in this particular case, water and climate and air quality and so on and so forth, right? So what you guys are doing is very valuable because you are actually validating what the Columbia University team is doing, saying, hey, I think it makes sense. And I understood most of it. And I was talking to Arena about this. I'm like, if there's a portion that you're reading and it makes no sense, write a comment saying, hey, this makes no sense. What the heck, right? So that's what this team is looking for, right? Because their job is to make
Yeah,
it clear and concise and readable and understandable to other people.
that's right.
Yeah. So I know we're nearing the hour and everybody is the weekend almost, right? Everybody's like, hey, I want to get to the weekend. Any questions or anything that you guys might have?
Yeah, quick question. Going off what we just discussed about, not knowing what we're researching and everything. One of the comments I did receive from Juan was about a quote unquote lesson zero that will help prime individuals answer basic questions, give them the basic understanding of the material that we'll be covering in these modules. Do you have any time frame or a time frame of when we might be able to see that or review that?
I don't have a specific time frame, but it is a priority for us. So that's, I'm one of the tasks. It's my task to do this lesson zero. I would say hopefully.
I think part of what could be great about this relationship here is for you to inform us about what it was unclear so that we can, develop a lesson zero that works for folks. So it is a priority, but as Juan said, we don't have enough manpower to do it too quickly.
Oh no, I completely understand that.
Yeah, I have started to identify certain themes that would go on the lesson, like, getting an Earth data ID or how to generate a token, what is RStudio or what is R and what is GitHub. But any additional, help on that or something that, of course, we've missed is great feedback, as the professor mentioned.
That's great feedback, Nick. And when you guys see that, you should bring it up. Even it may be a very, I'm gonna use a word I usually like a very stupid question that you think that's a stupid question, right? People are gonna think that I don't know what I'm talking about. Well, if you don't ask the question, right, you gotta ask the question. Say, hey, what is the context? Where are you coming from? What do you mean, right? I do this because I grade all the time, so I'm grading, and that's my thing. What do you mean? Give me an example. It's like it makes no sense, right? Those are the things I think that we're looking for. And before I forget, Juan, I read the whole module several times because I wanted to make sure I was very informed before we got all the team together here. If you need help with lesson zero, let me know. I'm willing to help you guys, right? We'll put it together, we'll write it, just let me know what you have and what we're looking for. And hopefully with the team here, with their valuable comments, they're going to tell us, I don't understand this part. We can integrate that part of in that first lesson or preamble of the lesson. So everybody knows, hey, this is what you're gonna need, you know, and this is how you do it, right? Screenshots and everything, so that people know exactly how to approach the entire lesson or module. I'll help
Yeah,
you.
that would be,
Yeah, thank
Yeah.
you. You know, and certainly we want to include you as part of our team as well. That's very kind of you, Professor.
Yeah, absolutely, guys. I'm here because you give us an opportunity to get involved, right? And the team here, everybody, hopefully everybody's excited with what's happening right here, right now, right? Is that your contributions will be lasting contributions, right? Whatever it is that you're gonna be doing in each lesson, and so I know it's 401, and for you guys it's 501 already on your side, is that towards the midpoint of the 10-week period, we're gonna start looking at the code, right? Hopefully it'll give you enough time, Juan, to kind of and Kate to go back to IC2 and say, hey guys, you know, your environment ready. We have people waiting in line, right, to use it. We're gonna probably spin up a little project where we can consolidate everybody's comments, right, into a single, you know, document for you guys. And you can look at this is the NLU document, review document, where it's gonna have everything. So let me start thinking about how we're gonna do that. I don't want you guys to worry about that. I think we can do it on our side, right? And that way when we're done with this whole effort, you guys will get a single document with all these comments together, right? Does that make sense?
It does, and I think really in the medium term, we should be thinking about how to use Git. You know, all of this is on GitHub, so like if we find issues in the code or things like, I mean, the thematic content is one thing, but the code is a different thing. You know, if we're making modifications for code, we should leverage Git and fork and leave comments there. Our project, you know, we're just not we've been doing a lot of things, but we haven't been able to do everything yet. So we've not quite gotten there yet.
Sure. Everybody, all the students here should have a GitHub account, because you guys took, we have a programming course, CSS 225, where we teach them Python, and one of the processes in the class is to get a GitHub account, because that's how we share code. Yeah, definitely. Everybody has all the links that you've sent me, Juan. I just share them, saying, guys, these are the links, right? This is what it is, and this is what it is, right? So they have those links. If you know, Nick, Jonathan, Iker, Jorge, you know, if you're missing all that stuff, please reach out to me. I'll provide those things to you again, right? Send me your photo, you know, shot, the best one that you can find. I'm gonna forward it over to Juan or an NK. That way they can put it on the website, and you guys can say, hey, I'm part of this group and we're doing great things, right? I think that's exciting.
Yeah, no, we'll also post this video and the slides to Zenodo, and then list us all as contributors. And then that's something I would really recommend you include as a published work on your resumes.
There we go. You're a publisher now. How's that? That's great. Anything else before I know we're past the time? Anything else? If you guys can think of anything else, please shoot me an email. You know, we'll talk about it. We'll get together again, right? I think Juan and Kid are pretty nice and good with their time. They can, you know, provide us more of their time if need be. Okay. Thank you so much, guys. Thanks everybody for making the meeting. I'm glad you guys are here. Hopefully you guys are glad you're here. Right, a lot of good information. I will follow up with an email for next week, and then I'll see you guys then. Have a great weekend. Juan, Kate, thanks for your time. Really appreciate it. And it's gonna be great. I want you guys to get that feeling, right? It's gonna be great. Awesome. Thank you guys so much.
Thank you. Thanks so much, everyone.
thank you. Nice to meet you all.
Thank you.
It was nice to meet you guys as well.
If you don't get the recording kit, let me know. I have access to it on my side.
All right, I appreciate it. Have a great weekend.
Thank you, guys. Okay, bye-bye.